Okay, just let me bring you up to speed of what I've had you to graph so far. All right, let me bring you up to speed. You don't have to copy this down. I'll tell you when you have to start copying it down. All right. Day one of graphing, we graph things that look like this, 4 cosine theta. All right. And what did we get out? Something that looks circle-ish, right? I'll just say circle-ish. Wasn't really a circle, had a couple little extra onto it. All right, it was a little circle-ish. Then the second day of graphing, I had you guys graph something with minuses and pluses in them. That was our hearts. The ones you did yesterday with the circle inside a circle, we all remember those, right? Those were called, and I may butcher this totally on the spelling, but my limacons. All right? We're good. All right. All right. All right. Limacon. All right. Here's where we're going today. And this is going to be totally different. All right. Because honestly, I don't know how much your table is going to help you out when we graph these. Okay. So at the bottom of this page here, can you start writing in just a little? I know I'm asking you to do notes May 10th. Some of you, your senior year. I know. I'm asking you to write down a couple notes. Here's what we're going to start doing today. R equals, there'll be a value out in front. Now there'll also be, and I'm going to put an N here, there will be a value in between cosine and theta, and there will be a value in front of sine and theta now. See how it's different from the ones we did on day one. I'm actually going to put a number right between here now. And that's not going to be a circle anymore. Okay? What it's actually going to form is called a rose curve, meaning it's got petals. Legit, like we're going to legit start doing things that look like this. That's the way it's going to end up. Okay, but I want to show you some tricks before we actually hit the polar graph. All right, I want to show you some tricks. This n value, pretty powerful. All right, the n value, pretty powerful. If n is odd, if that number in there is odd, all right, if it's an odd number, 1, 3, 5, we're not going to get any higher. That will tell you how many petals we're going to have on the graph. All right, that will equal the number of petals. Okay, so if n is odd, that tells me the number of petals. What else could be my other option? And it might not be odd, might be even, right? So if n's an even number, the number of petals is going to be 2 times that number. So I'm going to put 2n. Okay? So if you guys just take a little gander up on our first graph, what's the n value of that first graph we're going to do together today in a couple minutes? 2, it's even. So I'm not going to have 2 petals. I'm going to have 4 petals. Everyone see how that works? Okay, so I know you don't know where they are yet, and I'll get to that, but at least you can determine just by looking that this one right here, because 2 is even, 2 times 2, that tells me I'm going to have 4 petals on the graph. All right. We okay there? Because there's a lot more, Matt. Go ahead, I'll let you copy. I'm taking it slow today. So we're okay on determining the number of petals we're going to have before we graph. If it's odd, that's the number of petals we're going to have. If it's even, I multiply it by 2. Everyone else, we good? Okay. Last part, the A value. Whatever number's in front, that's the distance the petals will go out on the polar graph. So A will be the distance of the petals, and I'll show you what I mean right now. What's the A value up here for the one we're about to graph in a couple of minutes? 4. So that means every petal will go out to 1, 2, 3, 4, somewhere around here. That's how far it'll go out, every petal. So this will be 4, 4, 4 in a second. It'll go out to 4. Okay? We okay? Anybody questions so far? I know I'm throwing a lot at you now, but hopefully it gets easier. Last thing I'll throw at you. And that's sine versus cosine. If we're going to graph a cosine petal or a rose curve, a cosine rose curve, there will be a max distance at 0. And again, please guys, just let me write it down and we'll go over one together. If it's sine, the max distance is halfway. And I'll show you what I mean when we get to it. And this is only for graphs that are in this form, which is today. Okay, anything else, we can just use the table like we've been doing to plug it in our calculator, write down the values. Ready to go. We ready here? We ready? Let's do this. I don't even care about the table yet. I'll reference it in a couple minutes. I don't care. Look at the equation. 4 sine 2 theta. So first thing I need you to do, be able to do, especially Tuesday's quiz. Oh, those are going to have petals. That type of graph where I multiply by a number and I have a number in between the sine and the theta, that's going to give me petals. Again, somebody teach me now. How do I know it's 4 petals? 2 is what? Even, which means I'm going to have 2 times that number of petals, so 4 petals. And what's the petals going to go out to? A max distance of 4, because that's the A value out in front. Okay, so I'm going to have 4 petals, and here's the great part about this. They're going to be symmetric with that polar graph. You guys go all the way around. How many degrees do I have? 360. Yeah, you do. You have 360. And how many petals am I going to have? 4. So that tells me every 90 degrees, I'm going to have a new petal because it's symmetric. All right, 360 all the way around the polar grid, 4 petals. Every 90 degrees, I'm going to have a new petal. We good? All right, so where's the first petal then? Hold on. Hold on. Sine or cosine curve? Sine. This is what I mean by when I say the max distance is halfway. If I'm going to have a petal at 90, what's halfway? What's halfway? Somebody locate 45 right now on that polar grid. Somebody locate 45. Everyone see where it is? What's the radian equivalent for 45? Pi over 4. And what's your max distance for the petal again for this particular equation? How far is it going to go out? 4. So at 45, 1, 2, 3, 4. There's 1 point. Halfway, 90, I'm going to have that max distance of 4. Okay, so how do I create this petal? Here's where I would start referencing your table. Find the value of the one to the left. Find the value of the one to the right. So here's what I need to do in your calculator right now. What's the angle to the left of pi over 4? Pi over 3. So I want you to find the value of pi over 3. What's the value to the right? Pi over 6. So can everyone go ahead right now, just like we've been doing for, what, 4 days now? Find those values right now at pi over 6 and pi over 3. Because I need a little bit more than this max point. Can somebody let me know what you're getting at pi over 6? Pi over 6. Let's go. Guys, can you get work your calculator, please? Let's go. This is not a day off today. I know I grind you guys so hard in here. Anybody finding pi over 6? What are we typing in here? Pi over 6 is what in degrees if you're in degree mode in your calculator? 30. So either you're plugging in 30 or pi over 6, depending on what mode you're in, into 4 sine 2 times your angle. We all should be getting 3.5 maybe. 3.5? What mode are you in? Okay, so 4 sine, and inside that parenthesis, 2 times 30. We all good? Everyone all good? Okay, so at pi over 6, go ahead, graph 3.5 for me. 1, 2, 3.5, about right there. And then what are you guys getting for pi over 3? Most of us, I'm hoping, getting 3.5 as well. Check it, because you're going to have to do this on your own. Check it, make sure you can get 3.5. So at pi over 3, also 3.5. And are you ready to make your first petal? Okay, the petals always start from the origin. And again, this is why I needed these 2 points, so I have at least somewhere where I can put these curves instead of just that first point of 4. Here you go. There's your first petal. Okay, again, hopefully now you're starting to see why I needed that 3.5 points, so I have some kind of direction where to go. And there's going to be how many of these on the graph? Once you get the first one, and I think it's going to be pretty smooth now. How many are there going to be? 4, and you know they're going to be symmetric. We just found out they're going to be how many degrees apart? 90 degrees apart. Here we go. Here's how we're going to find the second petal. This was at pi over 4, which is what, 45 degrees? And you know they're going to be 90 apart. Where's the next one going to be? You're at 45 now. Where's the next one going to be? 135. 45 plus 90, right? 45 plus 90 brings me to 135. Anybody know where 135 is as far as radians go? Because that's where we're going to have to plot. Is what? 3 pi over 4. Yeah. And guys, guess what point we're going to have at 3 pi over 4? Guess what point we're going to have at 3 pi over 4? Oh, yeah, yeah. 1, 2, 3, 4. You can go to the chart now if you want, but guess what's going to be to the left and going to be to the right? 3.5s. Yep. How are we doing so far? Where's the next petal going to be? So 135 plus another 90. So 135 plus another 90 will be where? What's that going to be? 0, 5, 225? Did I do that right? Okay, where's 225? 5 pi over 4. Yep. 1, 2, 3, 4. We know what's to the left and to the right. Look at that beaut. As bad yet or no? Not too bad? Okay, and then where's my final petal? 225 plus another 90. So yep, it'll be at 7 pi over 4. Three and a half to the left and to the right. I don't know. I'm not the best, obviously, because those aren't the. What is that? Like I don't care. I'm just glad I got the point across. That's because it's at 3, isn't it? Yeah. Oof. Let's try that again. Yep, it is. It is. Yep. Yep. I didn't. I wasn't digging deep. I wasn't all in.
Where's your little hat? Where's your little hat? Where's the visor?
Laugh it up, kids. Laugh it up. Anything right there. We okay? It was nice the last 2 days. It was nice. I thought everyone was joking when they said you're at an AP exam. So those two, you've never seen those two letters next to each other. Come on, who are you joking? All right. Yes, Emma, go ahead. Yeah. Yep. Watch when we do the next one. The next one's going to have odd number of petals, but it's still going to be evenly spaced around 360. They'll be evenly spaced. Why don't you calm down, boss? Okay. All right. Okay, hey guys, we okay here? Next one's a little bit different though. Are we okay? Okay, here we go with the next one. Not as easy on this one. First, look, identify the equation. Everyone sees we got an A and an N value in there, so I know it's going to be a rose curve with petals. Talk to me about these petals. How many petals? There's going to be 3 petals because this is odd, and that's the number of petals. So 3 petals. What's going to be the distance again of each petal? 4. Yep. And now, do you see, is it sine or cosine? Cosine. So the max value of 4 is not going to be in the middle anymore. It's going to be right at 0. We're going to start. Okay, right at 0. Let me just refresh your memory. So if it's a cosine graph, the max distance at 0. And I'll show you what I mean right now. Ready? So your first petal is literally going to be on the 0. The max distance is what? 4. So at 0, I'm going to plot 4. I'm not going to go halfway in between like I did on the last one because this is cosine. And cosine, 1, 2, 3, 4. And I debated it or not whether to review this with you or not. Last night I was thinking this through my game plan in my head. But when we did the cosine graph ages ago, do you remember where the cosine graph always started at 0? At the max. Always started at the max, which was 1. Okay, well, calm down there. All right. This is know-it-all. Everyone remember it started at the max, right? So does this. So any cosine curve starts at the max, at 0. Okay, now remember, hey, all right, let's go. We still need to do the same thing we did for the last one, which is what's to the left and what's to the right. But now, well, actually, before I do that, 360, how far apart are these petals going to be spaced? How many petals again? 3. 360 divided by 3. I'm going to have a petal every 180. AP. 120 degrees. All right? 120 degrees. All right? Every 120. Happens to the best of us, right? All right, that's not even. We got to get through the first petal before we go 120, though. We got to get through the first petal. So take a look to the left and to the right. Ooh, they're not labeled for us. Anybody remember what I'd go by? 15 degrees. All right, I do go by 15 degrees. Any pi over 12? Yes. So this will be pi over 12. Anybody, or 15 degrees, that's fine. I'll put that there if you're going to plug that in your calculator. That's fine. And anybody, ooh, there's 20, well, there's 24 total. So this one to the left would be 23 pi over 12. And in degrees, 315 less than 360. 345. Okay? And that's why I gave you guys a blank table. You can fill in whatever you want right now into your table to show me what values you're calculating. Guys, stop. Are we okay on where these came from? The one to the right, one to the left. Okay, so in my, right now, I'd probably, all right, let me find the value of pi over 12 or 15, whatever mode your calculator's in, and 23 pi over 12 or 345, whatever mode your calculator's in. And what's our magic number for this one? It was 3.5 last one, but now it's, find it, guys, find it. So it should be 2.8. Everyone getting 2.8? Yep, 2.8. So that's our magic number, so I can get at least a couple more points, so I at least can make a decent pedal out of this. So 2.8, 1, 2.8, and then 1, 2.8. And there is the first pedal. Again, it's on 0 if it's cosine. All right, it's on 0 if it's cosine. We ready for pedal number 2? How far apart are the pedals? 120. I'm at 0 right now, so I'm going to go to where now? 120. Where's 120 up here? 120 as a radian. 120 is 2 pi over 3. Yep. So at 2 pi over 3, what point am I going to graph? 4. 1, 2, 3, 4. And then what are the points to the right and to the left? 2.8, 2.8, right? Guys, how are we doing? How am I doing with this? We all right? We going slow enough here? I know there's a lot to think about. How many pedals? If it's sine or cosine, how far is it going out? All right, 120. Where's my next pedal going to be? 240, 4 pi over 3. So 1, 2, 3, 4 again. And then to the right and to the left is 2 point. Why did I feel like I graphed something wrong? No, I did. I'm okay. Never mind. 1, 2.8. 0.8. Look at that butte.
Those look a little long.
4. That's a. Okay. Sorry. Guys, please right now before I end this, anything you'd like to ask, because you're going to try it on your own tomorrow with what, 2 more? And if you take a quick peek at tomorrow, look, you got 3 pedals for a cosine, which is just what we did, and you got 4 pedals for another cosine. So see how you do with that tomorrow. Okay, a little change up on that second one. You got it though tomorrow. All right. Hey, not bad. I thought that was going to go a little worse, but I never should doubt myself. 1 second, Emma. Got the